On our last problem, we have a quartic equation. And first, we're going to determine the general shape, and then we're also going to look at the y-intercept. So we know our general shape of the function, because x to the fourth is the highest power, is going to be like this. So have some sort of shape, both sides point up. The y-intercept, if I plugged in 0, all of these terms would go away, and I would just have 70. So because this has 5 terms, we don't really have a factoring method that will work to solve it or find the x-intercepts algebraically. So we're going to go straight to a graph. I already know the y-intercept is 70, so I'm expecting my window to be pretty big. I'm going to start out with a zoom 6 though. I already have the equation typed in and ready to go. If I press zoom 6, I'm going to just basically see these almost straight lines. We know the general shape, so we know we're looking for something more. If I go to my table, if I start to look at these numbers, I see at least like things around negative 200. So when I go to the window, because my graph does look pretty balanced, I'm going to use the same value, positive and negative, for the y min and y max. So when I go to my window, I don't know, let's just say I start with negative 200 and 200. So negative 200 to 200. That's not quite good enough. So maybe I try negative 300 to 300. See if that includes it. I think I just got a 3. Okay, so that did not, obviously is not right. So the zeros didn't stay. Okay, so not quite yet. Maybe I try 400. Okay, so negative 400 to 400. Okay, and that looks like a good window. That's not the perfect window. You could use something else, but we kind of want to see that whole graph. So looking at this, it also wants the x-intercepts. Looks like it crosses at 1, 5, negative 2, and negative 7. I can verify that it crosses at those integer values in my table because I can see that the y value is 0 at those points. So when I draw my graph, and I actually have the graph already done on this one, this is what my graph would look like. Miss Morrow used, or the other teacher used, negative 350 to 350 on hers. That's totally fine. I think this goes a little bit lower, but that's fine. As I said, it contains the whole graph and we can see it. So now we're going to work backwards. We have the graph here, and we want to know what are the solutions to the equation. Where is this function equal to 0? Well, the graph shows us that it's equal to 0 at negative 7, negative 2, 1, and 5. So without using algebra, solving this graphically, I know the solutions to that equation are negative 7, negative 2, 1, and 5. Now, pretty much all the time, we start from our factors. So let's say I'm solving an equation like this. This is not something you need to write down. And I factored it. So this came from x squared minus 2x minus 10. So I factor it and I solve. Now, the idea here is that if I know the solutions, I could also work back to the factors. So this next question says, write the expression. This is that same expression in factored form. So if I have a solution of negative 7, that came from the opposite sign factor, so x plus 7. This one came from x plus 2. And the positive ones came from x minus 1 and x minus 5. So we can actually use graphs as a way to find factors of expressions.